Okay, good afternoon everyone. So in our last class we have discussed about what? Counters. So today's topic is what? Memories. Okay. So what is about today's topic? What is meant by memory and what is the need of memory, and which parameters are there in our memory? Read operation, write operation. What is the access time of memory? What is the capacity of the memory? How can we define? And word length. Okay, and also the classification of memories is there, and working from static and dynamic. Okay, these are the today's topics. But before going to discuss about today's topics, once I would like to revise our last class topics. What is our last class topic? Ring counter. Okay, what is meant by a ring counter? It is a counter which is used to produce So once I would like to revise the need of memory read operation, write operation. Okay, once I would like to revise the last class topics. Those are ring counter. So what is the theme of ring counter? It is a counter where the output of each stage, each flip-flop is connected to the input of previous stage, and the output of the last flip-flop is connected back to the input of first flip-flop. So it looks like a ring fashion in the construction, and also in operation it would like to produce for every 4 clock pulses the same sequence is repeated. For every 4 clock pulses the same sequence is repeated in the ring counter. And while coming to the ring counter, where it is used means in digital counters and dividing frequency divided computers and digital clocks and industrial digital computer systems. So then here we are using ring counters where the repeated sequence is used where the usage of repeated sequence is arised, this we are using our ring counters. Okay, and different IC numbers also seen in our last class, which IC will produce which and counters. Okay, and the TTL and CMOS families will produce the counters, different asynchronous, synchronous, ring, decade, every counter. All the counters are available in either TTL family, also in CMOS logic family. Okay, and now see here, while coming to the today's topic, first one is memory. First of all, what is meant by memory? So our memory is there, human beings memory is there. What is the function of human beings memory? To remember something. To remember something, we are utilizing our memory. So generally also the purpose of memory is used to store some information. Where we store some information, simply that is called memory. So in our last classes we are already read about register. Okay, what is the purpose of register? It is used to store some information temporarily. Of course, whatever it may be, it is used for temporary storing or permanent storing. If any device is used for storing the data temporarily, that is called what? Memory. Okay, what is meant by memory? It is used to store the information is called memory. So while coming to the digital electronic, memories are used to store the binary information. What is the need of memory? Memories are used to store the binary information. And here the memories are made with which kind of devices? Registers. Okay, registers are used to store the binary information in the memory. Simply the registers acts like a papers in the book. Okay, here book, memory is called, means book is called memory, papers are called register. Is it clear? So we said book na papers, to store to write anything we are using books. So inside it containing papers. So while taking comparison, here the memory is referred as book and the papers are referred as registers. Okay, so this is about the definition of memory. Okay, and see here, it is a device that stores the information in electrical or magnetic or optical form. So already I told you, memory is a device that is used to store the binary information. In which form it stores the binary information? Either in electrical form, or in magnetic form or in optical form. And according to the method of access, the memories are of two types. How many types of memories are there? Two types according to the access. One is sequential access memory, other one is dynamic access memory. So see here, while coming to the first one, sequential access memory. So once you see this diagram, simple diagram, for example, if it is a memory having some number of registers, 0, 1, 2, 3, 4 registers are there here to store the information. If I would like to enter some bits 0, 0, 0, 1, 1, 0, 1, 1, 1, 0, 0, these bits are stored in register. Sequential access memory means, if it is a sequential means, the accessing of registers must be done sequentially one by one. That means if I would like to retrieve the data from second register, only I want the data in second register. First I would like to retrieve the 0 and 1, then only I retrieve the data from the second register. In order only we retrieve the content, then that is called sequential access memory. Is it clear? And while coming to the direct access memory, if I would like to retrieve the contents from the third memory directly without touching 0, 1, 2 register, if I able to retrieve the contents from the third memory, then that is called what? Direct accessing. Or otherwise, if I would like to enter the data into the third register without touching first, second, 0th register, if I enter the data directly into the third register, required register, then that accessing is called direct accessing memory. Sequential accessing means, if we would like to enter the data into one register, we may touch the other registers also. According to the sequence only we enter the data, then that is called sequential access memory. Without touching any other register, whatever the required register we want to enter the data or to retrieve data, if we access that register only directly, then that is called direct access memory. Okay, what is meant by memory? It is a device which is used to store the binary information. That may be either in the form of electrical, or it may be in the form of magnet, or it may be in the form of optical. Okay, it is a device which is used to store the information either in the form of electrical, or in the form of magnetic, or in the form of optical. Okay, and according to the method of access, memories are of two types. One is sequential access, other is direct. Okay, sequential access means, here the registers in the memory are accessed sequentially in one particular order. But in direct access memory, whatever the register we would like to use, either to enter the data or to retrieve the contents, that only touched, then that is called direct access memory. Is it clear? So once check the slide. In direct access memory, sequential access memory, this memory is accessed in a sequential or serial fashion. Already I said this. Access time is different for different location. For example, first register will require 3 minutes, the second will require 6 minutes. Why? Because by after retrieve the contents from the first one only, we would like to take second one. So that for accessing shift register 1, it will like to require 1 minute, and for the second one it 1 minute. For the second one, its total time is 2 minutes. One, see here, I would like to explain this simple diagram. So see, to access the third register in sequential access memory, first I would like to access first and second. So see, for accessing first memory, no time is there. But for accessing second memory, if first one requires 2 minutes and second one requires 2 minutes, so accessing of second one is 4 minutes. And for the third registers, these 4 minutes is required, and for these 2, so total 6 minutes. Means in increasing order, while accessing the registers one by one, the last register will requires full time. Okay, so in this way, the accessing time of arrays or the locations is different for the different locations or different registers. Okay, and see here, this is the circuit diagram of shift register sequential memory. So this is for what? Sequential memory, not parallel. So see, in sequential memory, which flip-flops are used here to store the bits? SR flip-flops are used. Okay, which flip-flops are used here? SR flip-flops, SR flip-flops. And how many number of SR flip-flops are used here? N number of SR flip-flops are used here. How many number of SR flip-flops are used here? N number of SR flip-flops are used here. And to see, for providing the accessing, gates are also used. For providing the accessing, gates are also used. AND gates are used. OR gates are also used. Okay, to providing the access, AND gates are used. OR gates are also used. And the data is stored in SR flip-flops. How many number of flip-flops are used? That is depends upon the number of bits are to be stored. If we would like to store n number of bits, here n flip-flops are used. If we would like to store one flip-flop, one bit is stored. If I would like to store 6 bits, 6 flip-flops are used. That means number of flip-flops are used to store the binary information is equal to number of bits. Okay. If I would like to store n bits, n flip-flops are required. If I would like to store 5 bits, 5 flip-flops are required. Okay. And once check, see here. Here the outputs are in the form of Q0, Q1, Qn minus 1. Okay. And with enable signal, see here enable signal is a write enable. If write enable is in active condition, the data is entered into the register. If it is in disable condition, the contents must be retrieved from the memory. The contents must be retrieved from the memory. And see, here the shift register holds one of the n bits of the keyword. So each and every time it will require clock pulse. Okay. With each clock pulse, the bits in the each register will advance one step and store words will appear sequentially, Q0, Q1, Q2, like that. Okay, already I told this. With enable line is set to 1, then only the write operation. If write enable line is set to 1 only, the write operation is occurred. Write means the data is entered into the memory. If write enable signal is equal to 0 means the contents must be retrieved from the memory. Is it clear? If write enable signal is set, the data is entered into the memory. If write enable is equal to reset means at logic 0, the data must be retrieved or recalled from the memory. Is it clear? And see here, this is the block diagram of memory unit. This is the block diagram. So once you check the block diagram, so in block diagram, first one, the data is entered into memory address register. Why here we are working with memory address register means the memory consisting of so many registers. Memory means it is the group of registers, so many locations. For example, if I would like to enter one particular bit, where it is stored, that is question mark now. So for that purpose, where we would like to store the data, in which location of the memory we want to store the data. So that is called what? Address. Okay. In which location we would like to enter the data, or from which location we will recall the data. Okay. What is that? To which location the data must be entered, or from which location the data must be recalled, is called what? Addressing. So why the addressing is essential? Why? Because the memory means it is not a single register. Memory is not a single register. It is a group of registers or a group of locations. Once see like this. For example, if this memory consisting of 6 locations, if I would like to enter the data into 4th location, here there is a need to mention the address of that location. If it is 0 and F, here there is a need of mentioning that address. In 0 and F, I would like to enter my bits. Okay. For that purpose, to storing the addresses, here the memory is attached to the memory address register. Is it clear? What is the need of address register? Why? Because the memory consisting of group of locations. So to store the data into that group of locations, okay, addressing of locations is very important. So to which location we enter the data, or from which location we recall the contents. For that purpose, we address that particular location where the data is entered or from which the data is retrieved. So that addressing is very essential. And see here the input address is entered first, then only the data must be entered. And here the memory unit also consisting of 2 control signals. One signal is called read and other one is called write. So read means if we apply the pulse across this read terminal, the data must be recalled from the memory. If read is equal to 1 means we can recall the data from any one of the locations from the memory. If read is 0, write is equal to 1, then it will indicate the write operation, means the number of elements must be entered into the memory now. The number of elements must be entered into the memory now. And see here the memory buffer register is also there. So this register is used to enter the data. So total memory consisting of 3 blocks. One is address register, one is buffer register, other one is memory unit. Total how many number of locations are there in memory? Only 3 locations: address register, buffer register and control signals. Here address register is used to enter the address of the locations in the memory to which or from which the data is accessed, and buffer register is used to enter the data into the memory. So the name itself indicates it is a buffer register. Whatever the data applied here, that as it is entered into the memory unit. So in between memory and the data, buffer registers are used for providing the smooth accessing. Okay. So next, the control signals are used to indicate whether the memory is under write operation or it is under read operation. So to enter the data into the memory, the write signal is enabled, means we would like to apply the clock pulse across the writes. Then only the write operation is enabled. Now we are able to enter the data into the memory. If write is equal to 0, that means if it is low, if even though I try to enter into the input here, it is stored in the buffer but it is unable to enter into the memory. Is it clear? If write signal is 0, even though the input is present across the buffer register, that is at buffer register only, it is not entered into the memory units. Is it clear? If we would like to recall the data, read bar signal means we need to apply clock pulse at read, then only we recall the data from the memory unit. Is it clear? Then only we can recall the data from the memory. Okay. So once again check what are the main blocks of the memory. See the diagram once. Address register is there, buffer register is there, memory unit is there. What is the need of address register? It is used to enter the address of that particular location of the memory. What is the need of buffer register? To provide the smooth accessing of the data into the memory, buffer register is used. Here through the in terminal, the data must be entered into the memory, and through the out terminal, the data must be recalled from the memory. And two control signals are there. These are used to specify the specific operation of the memory, whether it may be the write operation or it may be the read operation. If we apply the clock pulse at write terminal, the write operation means the data is entered into the memory. If we would like to apply the clock pulse at the read terminal, now the contents are retrieved from the memory. Is it clear? So this is about what? Block diagram of memory. And see, next one is types of memories. See, first memory is called according to their functional relationship with CPU, according to the So according to the functional relationship with CPU, memories are basically classified into two types. What are the two types? Main memory as well as auxiliary memory, based on which according to the relationship with CPU. So the memories are two types. First one is main memory, second one is auxiliary memory. And next second one, according to the method of access, memories are classified into two types: direct access memory, sequential access memory. Okay, first one is according to CPU, main memory, auxiliary. Next, according to method of accessing, either directly accessed or sequence manner, direct and sequence. And according to the type of accessing allowed, whether the memory allowed only the write operation or it may allow write and read operation. Some memories allow only read operation, means from, for example, if PDF file is there, we can only read the PDF file. If it is a Word file, which allow both read and write operation. So depends upon that, according to the type of accessing, whether it may be write accessing or it may be read accessing or it may be both. So memories are classified into two types: read only memory and read or write memory. Read only memory, read or write memory. And see here, first one is memory cell, a device or electrical circuit used to store a single bit is called memory cell. And examples of memory cells include a flip-flop, charged capacitor, and a single spot on the magnetic tape or disk. Okay, this cell means what? It is used to store a single bit, that is called cell. Okay, and what is meant by memory location? In cell, we are able to store only one bit, but in location, we are used to store group of bits. Why? Because memory location means the group of cells are called memory location. So memory location means here we are able to store n number of bits according to n number of flip-flops. And what is meant by memory word? A group of bits in memory that represents an instruction or data of some type is called a word. If it is a single bit, it is not called a word. If group of bits are there to give some information, whether it may be the instruction or it may be the data, if group of bits are there in location, then that is called memory word. For example, if a register consisting of 8 flip-flops, if we want to store the 8 bits in that memory, then that is called 8-bit word. Okay, and see here, next one is bytes. Already we have a very good idea about byte. Why? Because we learned it in our first unit itself. Okay, what is meant by byte? The group of 8 binary bits is called what? Byte. What is meant by nibble? Group of 4 bits is called nibble. Group of 8 bits is called byte. Group of 4 bits is called nibble. 8 bits is called what? Byte. Okay, and see. And here, what is the capacity? How can we define the capacity of memory? See here, The capacity must be indicated in terms of bit words. Okay, memory capacity memories are indicated in terms of bit. For example, phone memory, we consider phone memory, and gigabyte is there. While purchasing phone, what is the capacity of this phone? They said 4 GB, 5 GB, 6 GB. Means the capacity is indicated in terms of bits, gigabytes, megabytes, kilobytes. Okay, so that is indicated in terms of bits and bytes. The capacity of memories are indicated in terms of bits and bytes. Okay, and the next one is density. So what is meant by density? So here the memory device has the greater density than another. We mean that it can store more bits in the same amount of space. Okay, and what is the next one? Address. A number that identifies the location of a word in the memory. A number that identifies the location of a word in the memory. Each word stored in a memory device or system has a unique address. Okay, each word stored in a memory device, and the addresses are always expressed as a binary numbers are often used for convenience. Okay, the address are indicated with 000, 001, 0010, 0011. In place of decimal, we address the locations with binary numbers like this. It is a memory. The address of first one is 0000, next one is 0001, next one is 0010, next one is 0011, next one is 0100. So in this way the locations of memory are addressed. Is it clear? And next very important term is read operation. Okay, already I told you. So read operation means by the application of the clock pulse across the read terminal, the data must be entered into the data must be recalled from the memory. Reading means retrieve the contents from the memory. Okay, or the data may be transferred from one device to other device. From where we can retrieve the data, that memory is goes into the read operation. Okay, the operation whereby the binary word stored in specific memory location is sensed, detected and transferred to other device. Simply the process of retrieve the information is called what? Read operation. Okay, the process of retrieve the contents, the process of retrieve the information is called what? Read operation. This operation is also called fetching operation. So this operation is also called fetching. So retrieving the contents or receiving the contents is in single word, it is called fetching. And we will use both words, whether it may be fetching or it may be retrieving. Both are same. Is it clear? So read operation, the data must be retrieved from the memory. The data must be recalled from the memory. Here the word retrieved, recalled is also replaced with fetching. So reading means what? Fetching the data, retrieving the data, recalling the data. Okay. And the next one is write operation. What is next one? Write operation. So in the write operation, a new word is placed into a particular memory. In write operation, a new word is placed into a particular memory. Simply the process of storing the information is known as read operation. The process of storing information, entering information is called what? Writing operation. Is it clear? Retrieving is called read operation. Entering the data into the memory is called write operation. See here, storing the information. Okay, and see here, while coming to the next important one, access time. So it is the time taken by the memory either to enter the data or to receive the data is called the access time. Okay, so it is the time required to perform either to enter or to retrieve. So simply it is the time required to perform either write operation or read operation. For example, if one memory requires 5 seconds to enter some data, so what is the access time of that memory? 5 seconds. So that access time is defined as it is the time required by the memory. Okay, it is the time required by the memory to perform either the read operation or the write operation. It is the time required by the memory, okay, to perform either the read operation or the write operation. Okay, and see, while coming to the next broad classification, already classification is over, but here I would like to explain each and every memory in single line. So here mainly the memories are classified into two types now according to the CPU, primary and secondary. So primary is called main memory and secondary is called auxiliary memory. So in prime memory, which is directly accessible to the CPU. So it is directly accessible by the CPU. Main means if it is directly accessed by the CPU, then that is called main memory. Okay, if it is directly accessed by the CPU, then it is called main memory. So what are the examples of main memory? ROM and RAM. And which elements are used as the main memories? Semiconductor memories are used as the main memories. Okay, and here the stored elements are directly processed by the CPUs. Especially which data elements are, if memory is directly accessed with CPU, that is called main memory. These elements are made with semiconductors and the data in these elements are directly accessed by the CPU. And see, next, according to the active device, okay, according to the active device used in the memory, means which devices are used to make the memories. Memories are classified into two types. What are the two types? Bipolar memories as well as mass memories. Okay, what is meant by bipolar memory? These bipolar memories, okay, emitter transistor logic is used to store the data. Okay, TTL logic is there now. If we are working with TTL logic, then the memories are called bipolar. Bipolar means both majority and minority charge carriers are involved in the process. And the next one is mass memory. These are called unipolar. Either the majority carriers or only the minority carriers were involved in the process, then that is called mass memory. Okay, and see here, while coming to the next mean, according to the movement of data. Okay, according to the movement of data, the memories are classified into two types. What are the two types? Static memory as well as dynamic memory. Okay, it is meant by static. So here the static memory, the data is remains permanently even though the power supply is switched off. Okay, that is called what? Dynamic static memory. It is a semiconductor memory in which the data stored will remain permanently as long as the power supply is applied, without the need for periodically rewriting the data into the memory. That means what? Even though the power is switched off, the data is saved permanently into the location, then that is called static memory. Okay, static memory means what? Even though the power is switched off, the data must be, whatever the data we entered, that is permanently stored, is called static memory. So in dynamic memory, the entered contents will be loosed if the power supply is switched off. So this memory is called what? Dynamic memory. And see, Next one is secondary memory. So in secondary memory means it is not accessed by the CPU. So secondary memories are hard disk, floppy disk, magnetic, external memory devices. Okay, and the secondary auxiliary memory is known as peripheral memory. Why? Because these are connected to the computer, not inside. So if it is there inside, that is called main memory. If it is there outside of the computer, then that is called secondary memory. Okay, and compared to the first one, auxiliary memories are used for bulk storage of data. Okay, these are used for bulk storage, and auxiliary memory operates at somewhat slower than that of internal memory. Why? Because it is taken from outside now. And according to the method of access, memories are classified into three types: random access memory, sequential access memory, direct access memory. Okay, random access, sequential. Random means the term random indicates either from which location also we can enter the data or receive the data. Means what? For example, if memory contains 10 locations, according to my requirements, I may enter or receive the data from my choice without touching any other location. Then that is called random access memory. Sequential means if one memory containing 10 locations, to access a particular location, if I touch other locations also, then that is called sequential access memory. That means what? In sequential access memory, the locations will be accessed in a particular manner, in a particular sequence. Okay, means after completion of first location only we would like to enter into second. After completion of second only we would like to enter into third. And the last one is direct access. Here we are directly entered into our required location. Means directly we can access the required location. Either may we write the data or may we read the data. And see next one. According to the period of storage also, the memories are classified into two types. What are the two types? Volatile and non-volatile. Already I told you, if any memory will store the information permanently, then that is called non-volatile. If it is depends upon the power supply, then that is called volatile. Depends on power supply means if the power supply is eliminated, then the data is also eliminated. Okay, so next see here, once check the slide. In volatile memory, the stored information is depends on the power supply, depends on the power. That means what? If the power is removed, the information in the memory also will be lost. Okay, and in non-volatile, even though the power supply is switched off, the data must be retained, then that is called non-volatile. So ROMs are under comes into the non-volatile and RAMs are under comes into the volatile. And see, while coming to the accessing type, memories are two types: read-only memory and read-write memory. The name itself indicates read-only means the data must be read from the memory. We cannot enter the data or modify the data. And read-write means we are able to enter the new data or also having possibility of modify the old data. Next see here, already this one is over. Static dynamic classification. Okay, so while coming to the summary, here in today's class we are discussed about what is meant by memory and what are the parameters we are used in memory and what are the types of memories. How many types of memories are there in here? Direct memories, sequential memories, primary memory, secondary memory, and random access memory, sequential access memory, okay, direct access memory, and read-only memory is there, random access memory is there. Okay, now see here, a shift register can be used as a memory ledger or otherwise ROM or otherwise PROM. A shift register can be used as a memory. Okay. See, the memory which requires refreshing. Which memory requires refreshing? Static or dynamic? What is your answer? My answer is dynamic memory. Dynamic memory requires refreshing. Why? Because if the power is switched off, the data must be eliminated. Which of the following is volatile memory? Volatile. If the power supply is removed, the data is also removed. RAM, random access memory. See, is it clear? Which memory is volatile memory? RAM is volatile. What is meant by volatile? If the power supply is removed, the data is also erased. While coming to the important questions, see here first 5 marks questions. While coming to the 5 marks questions, draw and explain the block diagram of memory. That is the 5 marks question. What are the main blocks of memory? Address register is there, control inputs are there, buffer register is there, and also memory unit is there. What is the function of address register in the block diagram? To enter the address of particular locations, address registers are used. And what is the use of buffer register? Through buffer register only the data must be entered into the memory unit. And what is the need of control signals? Read, write. So to access the memory, must and should we have to apply the control signals. For doing the write operation means to enter the data into the memory. To enter the data into the memory, write control signal is enabled. Next, to retrieve the data from the memory, read operation is enabled. That means by applying the pulse across the read control signal. Okay. And memory means it's not a single location, it consisting a group of locations. Okay. Each location consisting of group of cells. One particular cell is used to 1 bit only. Cell means it is a single flip-flop, it is used to store 1 bit. Next one, location. Location means group of flip-flops are used to store group of bits. And what is meant by read time? Read operation. If we enter the data or retrieve the data. If we receive the data from the memory, then the operation is called read operation. If we enter the data into the memory is called write operation. Here fetching means what? Read or write. So fetching means retrieving the data or read operation. And one important term is there, access time. What is meant by access time? It is the time taken by the memory either for doing write operation or for doing read operation. What is meant by access time? The time taken by the memory either for making write operation or for making read operation is called accessing time. Okay. And while coming to the RAM and ROM, here RAM means random access memory, ROM means read only memory. In random access memory, the data may be entered and also must be received. Bidirectional operation is there. The data must be entered into the memory and must be received from the memory. But in ROM, the data must be entered into the memory once by the manufacturer only. Okay, it's not accessed by the user. Once the data is entered, that is permanently stored. Now we can only access the data, means we can only provide the read operation. We are unable to modify the data or we are unable to enter the new data into the particular memory. So when we enter the data into the ROM, read only memory, only at the time of manufacturing, once in the lifetime of memory, only one time we can enter the data into that particular memory, then that is called read only memory. So among these two memories, Read only memory is a non-volatile memory. That means the data in the read only memory is permanent. If the power supply is switched off also, the data should not be eliminated. The data in the RAM is temporary. Okay, the data in the RAM is temporary. If the power supply is switched off, the data must be eliminated. Power supply is switched off, the data must be eliminated. Okay, so in this way, in today's class we have discussed about memory and types of memory and which parameters are related to the memory. Okay, now I would like to close the class.